Okay. Why is this thing being a problem? Okay. So good evening, everybody. This evening we'll be talking about non-parametric counterparts of t-test. So day before yesterday, we briefly went through. Please mute yourself. If you are making noise in your hand, mute yourself. Went through. Who is making noise? Please mute yourself. Where is it coming from? Prof, you can mute yourself. You are not muted because everybody I see is muted. Okay, it's muted now.
Your cry in the mighty name of Jesus. To return to you, your ill-heart's desire in the mighty name of Jesus. You will not pray this prayer again in the name of Jesus.
Okay. Okay, let's start. I think this person has stopped.
Yeah. It's good now.
Yeah, yes. Maybe we'll look for a way of controlling the muting here. That should have not any. Once everybody is muted, nobody can talk unless I allow. Don't know why people are not disciplined. Okay. So we'll be looking at non-parametric counterpart of student t-test or t-test generally. And before yesterday, we look at t-test, the origin, the distribution, the different tests under t-test. And we also look at assumptions, around using t-test. So we realize that it's a form of parametric test. So you can only use t-test when some assumptions are met, like the data set following normal distribution, then homogeneity of variance, then also talk about the type of data set must be measured at least on interval scale, that is quantitative data, and independent. Of course, the last two, they are not as important as the first two. So you see that there are still some parametric tests that still violate the last two. But the most important are the first two. And we also discussed that if all those conditions are not met, in some situations, you may still rely on the robustness of the test to go ahead to do parametric tests, especially if the sample size is very large. We said that t-test itself is a robust test. Because all those conditions, they are not only true for t-tests, even all that parametric tests like ANOVA, surveillance. So in a situation where you cannot rely on the robustness of the test, the second feasible option is to conduct non-parametric tests. The last option that you should not first go for is transforming the data. So this second option now, because even the first option is not a situation that is advisable, like what Prof said in library for yesterday. Some people believe that you lose some accuracy. So in such a situation, you have for non-parametric tests. So each of the different type of t-tests also have their its own non-parametric counterpart. So that's what we want to look at this evening, the non-parametric counterpart of student of t-tests generally, not necessarily student t-tests. So as I've said, when the requirement for using parametric tests are not met, you can opt for it. They are called assumption-free tests because you can see we say there are some assumptions around conducting or using parametric tests. So when the assumptions are not made, there are some tests that you don't need assumption. So these are non-parametric tests. And you can also call it assumption-free tests. So rather than you know using the value, like in parametric tests for comparing means, you calculate the mean. You like an independent t-test, you calculate the means of the two groups. You minus one from the other and divide by you also divide by the standard error. In the peer t-test, before you calculate the mean, though each group has its own mean for the peer t-test, but you remove the one from the other, either post from pre or pre from post. No, I mean before and after, because you are dealing with peer group. So it is the mean of the difference you calculate over the standard error of the difference. Can you see? So the independent t-test is about difference between means, while the peer t-test is about mean of the difference. We also have one sample t-test where you compare this one sample, the mean of the sample you have with the population mean. So the same thing, if any of them, any of these three scenarios, in any of these three scenarios, you cannot rely on the assumption, the requirement for conducting them as parametric tests are not met. So you have to opt for the non-parametric counterpart. So instead of you calculating mean now and summing or whatever, you rely on the ranking. You rank the values because you know that the data is already skewed. So calculating mean summing or whatever, it will not solve the problem. So you rather rank, and there are different logic. So not like the way some people invented. Somebody first described t-tests, and from there, other intelligent people also follow to improve on it, to adapt it to many situations. The same thing also, when they saw that the limitation also is, if one of the limitations also, or the major limitation, well, in some situation, if this requirement, the assumptions are not met because you made some assumption. So intelligent people also invented this non-parametric. So you see that each of the t-tests has its own non-parametric counterpart. Now look at, for example, now t-tests and their non-parametric counterparts. You see, you look at the purpose, the parametric, non-parametric. When you compare a sample mean with a population mean, a sample mean means that you have data set for a group, but you don't have data set for the population because it's already published, the work has been done long ago, but you just have a value that this is the mean in the population. Or another population, you want to compare the mean in your sample with a mean in the population. It may be the same population, it may be other population. Whichever way, you are comparing a sample mean with a population mean. That is one sample because you are dealing with one sample. So if we are doing t-test, the data set is normally distributed, all these assumptions are met, you opt for one sample t-test. Otherwise, if the assumptions are not met, so the non-parametric counterpart is Wilkinson sign rank test. So you can call it one sample with Wilkinson sign rank test. So you will see also that all those names, you get to know once you know, you see Wilkinson, the Wilkinson that, but once you understand the logic, you won't miss it. There are logic behind it. Now, when you compare two independent groups now, two means is for t-test is independent sample t-test, and while for the non-parametric counterpart of that, it's either Wilkinson ransom test or Mann-Whitney-U test or Kendall's S test. All of them, logic are the same, just distribution. You see, the process is the same process you use to calculate the Wilkinson ransom test and Mann-Whitney-U. It's the same process, just like a different stages. You use the value at a particular stage, you go further with another one. So it's the same thing. So when you run it, you see the two, so just like somebody give you, say you want to buy a drink, malt or whatever, and by the time you want to drink liquid, but they give you, it's already frozen. And you allow, or you say you need frozen one. So you can collect it and go and freeze it, or if you allow it to melt. So the same thing, but at different stages. I mean, the Wilkinson ransom test and Mann-Whitney-U test, when you are testing the mean of the different impaired observations, that is the same group now, one group, but the data you collected is before and after, or whichever way, before and after, you in two times. One sample, you collected the data 2 times from the same sample, is paired. So as I usually say, with the word pair is a misnomer because people will think that you are pairing group of subjects. No, you are not pairing the subject, it's the observation you are pairing. It's the data you collected, you are pairing in one group. That is the data before and after. So you can see one sample deal with one sample t-test or one sample with Wilkinson ransom test, deal with one sample and compare with population. Two sample deal with two, there are two samples you are comparing. Pair t-test is one sample, but you carry out your observation in two phases, you took two measurements. So all of them, if you look at it, t-test and the non-parametric counterpart, you are comparing two things, different between two means. So either is one sample, even the one sample, there's one reference mean in the population you are comparing with, even though you don't have the data set, you are not using the data set. So these are the t-tests and their non-parametric counterpart. So there is, I talked the other time, I talked about, you also use t-tests also to do regression line, to actually evaluate regression line. Now, I gave some background from history about the student t-test because the first person to describe it, call it student. He actually described the independent t-test, sample t-test. And that was the first person to describe it. And that's why they call it student t-test. So when they say student t-test, talking about independent sample t-test. The same thing, Wilkinson test. All this Wilkinson, Frank Wilkinson was an American chemist. Year 1945 described all these tests, the non-parametric counterpart, popularized by Sidney Seger in 1956. So sometimes somebody may live before his time. When you describe something, they may not know, or by that time people's mind are not open. Maybe after the person has died, or maybe the person is no more, another person will now further the work. Now, this one is better understood when you give example, because I used to say the formula you see, the model, they are model, the diagram, table, figure, these are model of true life situation. So it's not the model you cram or whatever, or you don't cram formula, cram diagram. You understand the true life situation. You know how they use the model to represent the true life situation. With that, you won't find it difficult. So, for example, this is data on substance use and depression. Try to see if substance use is associated with depression. So here we have two types of substances: people on drug or alcohol. Now, in comparing the two, the depression, I did use back the depression inventory scale. There's a scale, the psychiatrists and those psychologists, many times because what they are dealing with is not physical. So sometimes they cannot take physical measurement. They'll take your blood pressure and say this or whatever. They only ask you some questions to assess and now give scoring. At the end of the day, by the time you see a psychiatrist and I ask you a question, how many times do you smile per day? Do you visit friends? Anytime you think you thought of killing yourself or whatever, by the time they had everything, they say, oh, you have depression. So that is their way. So they invented a lot of scale. I think it's a psychological scale anyway. But they give scoring, whichever way, doesn't really matter. So this is just an example. So for drug user and alcohol user, you apply the scale. These are the score. This one, why you see it in this way, we have score on Sunday, on Wednesday. During the week, it's possible somebody is more depressed than during Sunday when the person maybe at least go to church and listen to sermon. Don't know why, but we have different score on Sunday, different score on Wednesday. And both for drug user and alcohol user. So this data is very useful. You can use this. If you look at the arrangement of this data, it's good for me to explain this. You will see substance use, drug, the first 1 to 10 are drug user, the 11 to 20 are alcohol users. So both of them are 10-10. So this, can you see now, is enter the substance use status is enter in series. In series, it shows that there are two independent groups. So when you have two independent groups, when you're entering into, this one is just a table, but that's the way it appears in your software, maybe SPSS or Excel, the way it appears in the table, because they are independent groups, so you enter them in series. That is, in series means that when you finish entering one, you continue with the other one. So if we look at it, we are not using, what we are looking at, the outcome variable here is depression score. But what separates, what differentiates the people that took drug? Because this person want to compare the depression among drug user and alcohol user. So what separates the depression score is there. Then there's a variable. It's the outcome variable. Is the mean of the depression. When you had the value in each group to calculate, you can calculate the mean. Is the depression, the mean of the depression in the two groups you want to compare. So that group variable must be there, so which is what differentiates the drug user from the alcohol user. So what I'm just explaining here is that since there are two independent groups, you enter in series. It doesn't really matter the one you enter first. It doesn't change anything. And it's possible you can enter the alcohol first and 1 to 10 and enter the other one. Doesn't even you can even enter them faster. So far you put the substance the person is using under the substance use. So when you are, even if you miss all of it, there is a variable that separates the two. It doesn't change anything, but why it is good for you to not to make mistake, you now arrange it orderly. But whichever way, just know that it's in series, they're online. Now, but if you are dealing, because this table incorporates these two situations, both independent situation and peer situation. The same group also, the same person that took drug, you can see the score on Sunday, the score on Wednesday. Now you see they are in parallel because You took the measurement 2 times. You assess them on Sunday, then the following Wednesday following the Sunday, you assess. So you took 2 times. Can you see? That one will be in parallel. What it means that when you are entering, the Sunday is a variable on its own. The depression on Wednesday is a variable on its own. You will not go and put it at the end of Sunday and say, oh, I'm entering Wednesday. No, because it's parallel for the same person. So like this 15 now, this person, one person, number one person may be Mr. Anything, Mr. John. Mr. John scored 15 on Sunday and scored 28 on Wednesday. So because one line is for the case, for the person or the subject. So whatever any other thing, even if it is height, weight, or whatever you are putting on that line, is anything from that person you put that line for that person. You see now. So if that is the case, if they are different group, each person entity in the group will belong to different line. But the data you collect from each person must be on the same line. So can you see now? So the peer observation, when you are doing peer, it is in parallel, while the independent is in series. I think the explanation is very clear. So the man Whitney U, as I've told you before, both the Wilkinson rank sum and man Whitney U is the same process. So let's use this example just to see the logic behind it. So you'll be able to understand the logic behind it. Because it's not, I don't start with example now, it's going to be writing one formula for you does not make any sense, because most of why it is easy for you to conceptualize that of the student teacher, even with formula without even example, is because most of the time, most of the invention in statistics come from the quantitative variable. It is later you now adapt it to qualitative. Or most of the time, it comes from a variable that is that follow an assumed distribution, maybe normal distribution. It is later that some people not okay. We can adjust this thing to measure the one that not follow normal distribution. So using the data set in the above table now, let's imagine a scenario in which there is no difference in the pressure. I want to say, okay, don't mind me, the estasis here is the drug and the alcohol user. You want, okay, I put it say there's no difference in the depression between the drug user and the alcohol user. If we are to rank, I say it's ranking. You rank the value. You see the way you rank. When you rank, first of all, ignore the group to which a person belongs from lowest to highest. If there's no difference, so you rank. If you are ranked, you start with 1. The smallest will be 1, 2, the value. You first of all rank all of them. Like in this case now, there are 20. 10 use drug, 10 use alcohol. So you rank from the smallest score to the highest, irrespective of which the group you belong. If we were to rank the data, you see that if there's no difference, we expect a finding similar if there's no difference. If you see some low value, almost equal number of low value will be on both sides. You see low value on both sides, high value on both sides. So to be somehow evenly distributed, if not perfectly. If we also add up the rank, we expect the sum rank to be about the same, because this one has as much as low value as this. This one has as much as high value as this. So if you add them together, even though you may find different, but the difference should not be much, or should be the same. Another way around, let's imagine there was a difference between the group. Let's say the drug is more depressed, the drug users are more depressed than alcohol group. If you rank the score based on this line, we will expect the higher rates to be in group. If the pressure is more in the drug user, so we expect the higher rank to concentrate the drug user, and the lower rank to concentrate in the alcohol group. If we sum the rank in each group, we expect the sum of the rank to be higher in the drugged user because the depression is higher there. But if it's the same, the difference will not be much. That's the law. Can you see that? Look at the same data set now. Look at the way it is put on the table. You see. Just don't mind the something. I'm dealing with two groups now, where 2 days. I'm looking at them as this one is looking at independent group. So it's looking at on Wednesday comparing the independent group, on Sunday comparing the two independent group. So can you see now? These are the score, the alcohol, the first 10 alcohol, the next 10 drug, the same thing here. So if you look at the horizontal now, it's 20. So you just put the value. You now give it rank. Begin to give rank. Potential rank, that is, you begin to rank them 1, 2, 3, 4, 5. You first of all have to arrange them in ascending order. So you arrange them and you give it the rank. So when you look at the rank now, you see, no, it's not necessarily ascending order per se, but you just give the rank. Look at the potential rank. These are the spot, the potential rank. 1, 2, 3, 4. This is the rank. Now you will see that yes, we have arranged them ascending order, but you will see that there are some that are like 6 now. Score of 6 is 2 times. So 6, 6. Look at another place, 35, 35, 35, about 3 times. So you cannot say, you cannot rank 1. Look at this one now, it's number 16, 17, 18. You cannot, this 35, you cannot give this one 16, 17, 18, and give this one 17 and give this one 18. The same thing with 6. What you do now, this is first potential, just rank them. We now go to those ones that tie rank. Those tie rank, look at these 2 6, 3 and 4. You now add 3 and 4 together and divide by 2. It give you 3.5, 3.5. The same thing, there are 3. You will add them together, divide by 3. It will give you 17, 17, 17. You look for the middle, that is the average for the group that tie. So we give you the actual rank. So of course, you know this thing has been arranged in ascending order. And okay, anyway, this is arranged. It's not actually, it's arranged in ascending order. All this one just write here, alcohol and drug, is just to write on that, to put the sum. It's not, so it's, I've already arranged them in ascending order. That means they should be able to identify. Look at A mean alcohol. Look at A. D mean drug. So I didn't just change this one. EMC mean the drug. ST6 mean the drug. Now, it's the same thing we do. So you can see the logic now. When you have done that, you will now calculate. Look at the, from there, what you do, you try to sum. So you know this one, we keep saying rank sum. After you sum, you rank. And you see now, you sum, after you rank rather, you now sum. You now rank, you now sum the rank for each, for alcohol, sum the rank for drug. You know, from this data now you can see that more of the alcohol score lower, while the drug score higher. So because of that, when you rank them, more of the drug will be at the upper spectrum. So when you now sum the rank together, it will give you higher rank. Look at it. On Wednesday, this the sum of the rank for this for alcohol is 59, while for drug is 151. While on Sunday, the sum of the rank for the alcohol is 90.5, and for this one is 115. Now, when you have done that, the formula for it is just okay. the sample size of each of the n times n. Then that higher one, the higher rank, n1 plus n1 plus 1, n1 minus multiply in bracket, multiply by n1 plus 1 minus r1, which is higher rank, higher sum rank. This one divided by 2. So when you just do that, this is for Sunday, this is for Wednesday, you will see that the value is smaller on for this Sunday. But the issue there is in the process of doing it, when you, if look at what I say, when the group have equal number of participants, the statistic W for the Wilkinson ransom test is simply the sum of the rank in the smaller group. If they have unequal number, of course, the smaller group, the rank, because when you do it, it will be smaller. Why the other one? No, your test statistic, if you remember when we were discussing, was it last week? I've said it many times also, that as the test statistic go higher, the corresponding p-value go lower. So the higher the statistic, the smaller the probability that you have made type 1 error, or probability that the difference due to chance. So that the higher the statistic, the more significant, because when the probability that you have made error is low, it means that it's significant. I said that it's only this my with you and Wilkinson that is different in all the statistics. Their own is the lower the value, the higher the lower the value, the lower the probability that you have made error, the higher the significance. So you go for the smaller one. So from this one now, you see it's the same thing I've come to run here. The statistics here is, for this one is 35.5, for this one 150, this one is 4. So for Sunday is 35.5. You will see that if you go and check the table, I didn't put the table here. Normally, if it were to be in those days where you go and check statistic table, you have to go and the critical value. You have to check the corresponding critical value. But in this case, the computer is there to check. I run the thing in the SPSS. You will see for Sunday, look at it. Man Whitney U, 35.5. For Wednesday is 4.0, which is what you see here. Can you see? And if you look at it, the corresponding p-value is significant, less than 0.001 for Wednesday, and is 0.280. No, it's the first one. It's a 269. So is this difference between the two groups is not significant on Sunday, they're significant on Wednesday. You will see that the value for Sunday, Wednesday is smaller, because the smaller, the more likely it's going to be significant. I think for that degree of freedom is 1 degree of freedom is critical value is 11. So 4 is less than 11 to be significant. While 35 is more than 11, 35.5 is more than 11, greater than 11, it will not be significant. So I think let's take it bit by bit. I think maybe I should stop here. Let's ask questions. Because later, maybe in the next one, we'll now look at the example of the pair. Because this area people are not familiar with. I don't want you to be flooded with much information. So I believe some people have typed their question. Let me just stop here. Let's ask question. Let's see if they don't have question. Kevin. Yes, we have 27. There we have a lot of people today. That's great. Okay. Yeah, I have checked the chat. There are no question yet. Any question? If you want to ask question, you unmute yourself because I will not hear you if you just talk. So if there's no message, okay, good evening.
Good evening, sir.
Good
Sorry,
evening.
sir, my question, the part I didn't understand was that slide that said when the group sizes are equal, the value, I'm trying to see that still, I was trying to just.
Oh, okay. Yes, okay. Okay. I think there's something I didn't say there. Okay, I know what you are saying. There's something I didn't say there. Yes. It's okay.
Right.
There's something I didn't even show you. You know, I told you that the process of calculating the Wilkinson ransom test, ransom statistic, and that of my Whitney U is the same, but they are different. But it's just like water and ice block. Now, you notice something. When the group size are equal, its value of the smaller group rank, smaller sum rank. In this example, the test statistics are 59 and 90.5 for Wednesday and Sunday, respectively. Look at the sum. The smaller sum, this smaller value is the Wilkinson statistic. The formula you see there is my Whitney U. So for Wednesday, the Wilkinson is 59. For Sunday is 90.5. Is the smaller value. When you do the ranking, the smaller one, when you now sum, you know there are two groups. The smaller value, that is the statistic. For Wilkinson, that is Wilkinson statistic. But if, let's say they are this thing, they are unequal, the smaller one, the one that has the lower number, that would be the statistic. But when they are equal, is the smaller value, that would be the statistic. So in this case now, it's the same group, and it's 10-10. So you see that, you know, there are two, it's like two data sets here now, Wednesday and Sunday.
Yes.
Between drug and substance.
Yes, sir.
So when we sum all the rank for alcohol,
yes,
it's 59. When we sum on Wednesday, when we sum the rank for drug, is 151. So the Wilkinson is the smaller one.
Yes.
Yes. On Sunday, when you sum the rank for alcohol, is 90.5. For drug is 119.5.
Okay.
The smaller one is still the Wilkinson, 90.5. Yes. But whether I think you get the logic now. Now
that's the smaller one is the alcohol.
Yes, it doesn't really matter. You won't say you are not interested in alcohol or whatever. Now, it's the smaller one, the statistic that show the difference between them. The smaller value is irrespective of whether alcohol. You won't say the smaller one is alcohol. We know that smaller one is alcohol, but it's the smaller value you are now interested in.
Yes,
that's Wilkinson. Okay. But in my Whitney, you now use the value to calculate something. So you will not get. Can you see now? So in this our example now, the Wilkinson for alcohol is 59. You get it now?
Yes, sir.
No, what I say for alcohol, not for alcohol. For the Wilkinson for Sunday, is 59, and Wilkinson for Wednesday is 90.5.
I thought it's 59 for Wednesday.
Sorry, it's the other way around. The Wilkinson for Wednesday is 59. For Sunday is 90.5. The corresponding for Wednesday now, the statistic is 4. Is the way I put it. The Sunday the my Whitney is 35.5. Look at it so that it doesn't confuse you. Look at when you're running with SPSS. My Whitney U. Can you see? Where this is Sunday, 35.5. The Wilkinson is 19.5.
Oh, okay.
So for Wednesday, the my Whitney U is 4. The Wilkinson is 59. It's the same thing. You can use hand to calculate here on the table. So that is why I don't want to, because if the logic also for the pair something is different. That's why I don't want us to talk. So maybe Tuesday we'll talk about the pair. Because that one is about sign. You have to assign sign. That's why they say a sign rank. That one is sign rank. This one is rank sum. Can you see that there's nothing like sign plus or minus? Because in that one you are removing, because it's paired. You remove before from after or after from before. In that case, if the one you are removing, in a situation where the one you are removing is higher, it will give you negative. If it's smaller, it will give you positive. So we assign positive, negative. That's why they call that one sign. That sign means positive or negative sign. Sign rank. You sign and rank. When we get there, we sign and rank. But this one you rank and sum. That's what we did here. For independent, you rank them and you sum for each group. You get the logic now. So you see logic in the issue is that you discover that even the non-parametric are easier to calculate than parametric. It's only that people don't know. It's not popular. So well, it's easy here because the sample size is very small. So thank God, even when you are talking of 300, 400, or 1,000, the computer will do it for you. The essence of this example is for you to get the logic behind it. So when you get the logic, you know how to use computer to draw it. You run it. It's fine. So I don't know if there's any other question.
Thank you, sir.
Welcome. Any other question? I was thinking mean is for parametric and median for non-parametric. Yes. You see? Yes. Okay, so you can talk. You can go on.
Yes. In the analysis that you run.
So what are you saying, man, sir? I can't hear you. It's like there is a problem. So if maybe you send a test, maybe you chat. Maybe you should chat us, sir, because we are not hearing you. You chat us. If you chat us, we'll be able to attend to your question. So let me read. Somebody said something here. He said, I was thinking mean is for parametric and median for non-parametric. You see, that's the problem. Many people have been raising this question. If you see what we just did now, did you calculate me? You didn't calculate me. You didn't calculate median. So when we say we are comparing two groups, we just use mean to compare. If the group we are comparing, we just use mean. The only thing is that when something is skewed, the mean is not a good representative. Median is a better representative. But when you are doing this, we are doing like this one I just demonstrated, apart from maybe one sample, ranks, sign rank, which even use median. All this one, they don't use the median. They don't use the median in the sense that the mean does not come here, the median does not come here. It's just like you are just using a non-parametric method. So many people they say that we are not comparing mean here, and whether we are not comparing median, we are comparing the two data, the two groups. That's just the logic. So many people they say that even in this one they don't use the mean. They don't use the median. It's only one. When we talk about it, maybe next week, we use the median to calculate. And just like the way you use mean to calculate the other one, you just use mean. So what if you look at a data set, we have different way of summarizing. It's the same data set. The data set has mean, mode, median, standard deviation, and many things. So it's just like in the family, you have the father, mother. So they may say, okay, the mother cook for the family most of the time. The mother tried to, the father tried to fend for the family, bring money or whatever. And the young one also, there are some things the men like to carry something. So it's in the family. So a particular data set has many characteristics. It has mean, median, and mode, and many other things. So when something is not normally distributed, because the mean is constrained, because it just happened that the parametric test used for the comparing mean use mean, it doesn't use median. But even the non-parametric is only one of them that use median. They use neither mean or no median. You see here, you didn't mention on mean or median here. So that's just the logic. So many people, even if I put my data, either is Q or not, I can see the episode, okay, mean, this is mean, mode, and median. The one that is not normally distributed also has mean, mode, and median. But from the judgment, you know that when it's not parametric, it's better you summarize, because the mean will be go to the extreme. For example, now when we are talking of income, it will not be fair to use mean to represent income. If you are to use mean to represent income in Nigeria, you will see that the average income may be as high as 200 and something, or over 100,000, or close to 100,000 average income in Nigeria. But you know that a lot of people are earning, it's few people that are earning high because of that skewness. Because the reason is that some people are earning 10 million, more than 10 million in a month. Some people are making more than 3 million, 1 million, over a million. Though they are few, but it affects when you use to calculate the mean and the mean. It jacks the mean up. It giving the impression, oh, the average, this is average of Nigeria. Whereas many people are not even getting 1,000 in a day, in a month. So, but if you use median income, you'll be surprised that it's around 10,000 or even less than that. Median income in the country, maybe less than 5,000 say. So that is why it's good to, when you are quoting, it's good to use the median. But when you are comparing, so even in a non-parametric something, it's good you show the mean and median. I don't know if I've answered that person's question. Now, how do we interpret or draw conclusion? Okay, that's a very good one. I think I said it. Some people may come late and on they miss one sentence or the other, throw you back. Let me just show you. I think I talked about that. You see, the drawing conclusion, look at like for the critical level. Now, because look at the p-value. Look at the p-value here. This one is 4. The critical level for them is 11. That correspond with 0.05. If you choose 0.05 as your level of significance. So this 4 is less than, and the smaller the value, the more significant. As I told you, it's not like other statistics. Because other statistics, the bigger the value, the less the p-value, the more significant. But here, the smaller the value, the less the p-value. So the p-value and the statistic go in the same direction. The smaller they are, the more significant it is. So that is so if the p-value is the value is less than the critical value, and the p-value is actually less than 0.05, like this one now, the p-value is less than 0.001. Look at the p-value for Sunday is 0.269. It's not significant. So on Sunday, there's no much difference in the depression, between the two groups, the drug user and alcohol user on Sunday. But on Wednesday, there's much difference significant. I don't know if there's any other one. Yes, I don't know if there's any other one. You can ask your question if you have. Yes. Okay, somebody's saying. Okay, thank you, Dr. Duaye. Yeah, any other one? Any other question? Okay, there's I think it's Dr.
I thought I answered a question.
Okay. Go on, sir.
Okay, I said there are two calculated terms, U and W. So which one does one report?
Okay, thank you, sir. If you look at it, okay, it's good just to refer so that we don't talk into the. That was why I said let me just take it once more. Let me just show you. If you look at the results, sir.
Yes.
Let me put the pointer. You will see that there's Man Whitney U, there is Wilkinson. Wilkinson is the W, Man Whitney U is this. Both of them, they are different statistics, they are doing the same thing. But you'll be surprised, you look at it, the p-value is for both of them the same because they are measuring the same thing. So if it's going to be for the same thing, if it's going to be significant with Man Whitney U, it will be significant with Wilkinson W. If it's not going to be significant with Wilkinson, it will not be significant with Man Whitney U. Look at that's why they're sharing p-value. They even put another one is an intermediate Z there. Can you see? Now let's look at if you look at the calculation when we're doing the calculation, I said something. You will see that the value of the Wilkinson is an intermediate intermediate value before you reach that Man Whitney U. So when you rank, you now sum. You have gotten W. This is W, the sum of the rank sum. So like the one that had the smaller one, you know, you're having two groups. When you sum for the two groups, the smaller one is the Wilkinson. Like in this case now, we know Sunday's own. I say Sunday. Yes. Sorry, I say Sunday. Alcohol. You know, maybe I should separate because this thing now, because I put two things together, I will like just use one. Alcohol is smaller rank. Yeah, but it doesn't really matter. You know, somebody asked me, alcohol is the one. No, it's not alcohol, it's just the value. The smaller value, irrespective of where it comes from. The smaller value is the Wilkinson. In this case, 59 is the smaller value. On Sunday, 90.5 is smaller value. Can you see? Both of them are the statistics, and the corresponding value, you see them. Whereas they now use the same, you go further to calculate. But in calculating here, they use higher value between both of them to calculate the Man Whitney U. Can you see? Use higher value. Why the other one look at the smaller rank? Is the smaller sum of rank sum. That's Wilkinson. But when you now use the Man Whitney U now, and uses the higher value between both of them. Look at this one now. For Wednesday, 151 is the higher value. That's what is used here. For Sunday, the higher value is 119.5. Can you see? So for Sunday, it's 119.5. If you put in as R1, the higher value, to calculate the Man Whitney U. But they are saying the same thing. I don't know if I've answered your question, sir. Have I answered your question? It's not, we are not hearing you. I don't know, maybe, is it raining there? So please, why is the smaller one for, well, yeah, to be sincere with you, if I find out, I will let you know. I don't know, but the maybe it's the person that invented it. You're welcome. I will leave. It's possible there's a reason for it, but I don't know. I will find out.
Okay, sir.
Yeah. So any other question? Any other question?
Hello, sir.
Okay, go on, sir.
Yes, sir, good day, sir. Thank you for the good lectures. I just want to know, is there any specific reason to choose Man Whitney, Wilkinson, or Kendall, or is it just mere preference for any of one of them?
If you look at it,
yes,
I think that Z is maybe that Z. I will look for the mathematical logic behind it. but I think I've encountered that Z is the candor. If you look at it, it's the same. You know, it's like, you know, intelligent people, when you are trying to provide solution to a problem, you end up, you know, different location. You may be in Maiduguri, somebody is in Lagos, and you are providing solution to a problem in different way, and you end up providing solution, that is that solution, using different method. That's what has happened. You get it now. So there's nothing. But the Wilkinson, the man with me, you is popular because people say man with me, you, or sometimes Wilkinson. Hardly will anybody talk about Kendo. It's the same. If you look at it now, it's just like somebody came to give you. You say you want to drink cold mineral. Somebody give you the minerals. You put it in fridge to become cold to drink. If you want to, you say you need mineral, they can either give you the one that is not cold or the one that is cold. So if you get the one that is cold, you pick it. If it's cold mineral you want, you drink it. If it's the one that is not cold, you allow it to, you know, to get warm some before you drink it. If they give somebody that is one cold one and it's not cold that is available, okay, help me put it in the fridge or to make it cold. It's the same thing. If you look at it, the Wilkinson, he said that you use the one that has the smallest one. Another person want to calculate to get the same thing. I don't know if you get it now. So there's no, but those people. Somebody has a question. Who's your doctor? Who's your man? You are talking. If you know that you are not asking a question, you want to talk, you can just mute yourself so that it doesn't disturb others. Thank you. So I don't know, Dr. Babagana, have I answered your question?
Yes, sir. Very well, sir. I understand perfectly.
Thank you.
It's like you said, we're used to do man weakness, so that's why.
Exactly. When you just say it, exactly. If you look at it, when you run it, it gives you both the value, but it depends on what, but they give you the same p-value, the same answer. So it depends on what, you know, if you are presenting to some people, they are familiar with it, you better use what they are familiar with. Because some people can fail some people because that person did not use what the examiner is familiar with. Our own examiner don't wait to, sometimes they even reason with students, maybe this student have found out new thing, let me even learn. Here in Africa, the teacher knows everything. Well, that is not always true. The student can know more than teacher. In some situation, yes. Yes. So I don't know if there's another. So yeah, somebody say, okay, where are we? Maybe I will send the slide. You know, I'm having issues. Somebody say, I will send the slide. Maybe I will send. No, I'm having issue when it comes to the voice. The voice is very, the video is very heavy. Loading, uploading. So the website, I'm trying to rebuild another one. But though the website, some of them I put all those ones, some of the one we have done. But on the website, you won't download, you can play it there because they are very heavy. So, but the slide I will send to you, I will send it. Maybe I just put the slide on the WhatsApp. Okay, how would we, okay, any other one, any other question? Okay, there's no question. Should we call it today? Or if you can, okay, somebody just send. Somebody kindly give your WhatsApp. Okay, you know what you do. If your number is not on the WhatsApp list, just chat your number to me now. If you chat your number, I will include any number because I'm seeing some name that we have not seen before. So chat your number. I will just, if you don't want to, you can chat it privately to me if you don't want people to see. Chat it privately. That's the way you can chat it privately. So I will be the only one that will see it so that I can include you on the WhatsApp because what I do is just send it into the group. Rather than clicking many people, be sending one by one. So once I put you there, I'll just send the link. Okay, thank you. I've seen it. I've seen it there, Dr. Droye. So just start your number. I will get the number after the I will make sure I save the number and add it to the group. Yes, somebody said the website. Okay, let me share the website. Though the website temporarily now, you can still use it because I put some things there. But very soon I will do another one that is easier because the provider is not user friendly in some sense, and I don't want that. Number one, the name is long and many things. I cannot do it. So do the one that is more user friendly. You can easily access this material. So thank you. I'll just shout my own the website now. So if you have any question, okay, I don't know if some of these chats say if somebody is asking question, okay, it's number you are giving. Let me look at. So you can see I've sent the website. You can see it, you can copy. Okay, I will even put it on the WhatsApp again, don't worry. Even the website, I will put it on the WhatsApp again. I will add all this number, I still put it. So once we finish the lecture now, we close. I will just add the number, include them, I will put it again. At least maybe in the next 2 weeks, the new one that is more user-friendly will come. But this one, so you can see download a lot of material from there. And if you cannot download, you watch some of the videos that are there. Thank you. I thank everybody for listening. So there is training by weekend starting from tomorrow. The training is on comparing means. So we're going to talk much about the t-test and all these non-parametric counterparts, interpretation of result, confidence interval of difference between means. So each of them. So the training affords me opportunity to go deeper and spend more time. Then allow you, after explaining something, allow the participant to share the slide also. To at least if you want to, or if you don't want to use SPSS. I send the data, all this data file, and the data file to the participant. So you run it, I allow you to run it, I tell you what to do. Click on this and share your SPSS with the data and tell you how to do it. So it's very, very important, especially if you want to have the skill and want to get deeper knowledge of it. So I think the poster is on there. I will resend it also. I will resend it. Just a minute. Yes, e-training. Yes, somebody has. It's on Zoom. It's on Zoom, and when I started, I wanted to start. Somebody asked a question. How will you demonstrate with SPSS, TTV SPSS, and very fantastic. In fact, I now discovered that the advantages of using Zoom, using Zoom for training on SPSS is outweighs its disadvantages. While the physical one, the disadvantages outweigh the advantages. So the physical one, you may say, okay, that the person is present physically, but it's difficult. One of the major disadvantages of the physical one is that it's difficult to organize because, okay, many people connect from different parts of the world. Some people connect from London to, on this Zoom to be part of this lecture. So for you to get a critical number to come and do training in a particular location, either Madugri or whatever, most of the time you hardly get. So the person will not come and train one person in a location. So you discover that you need this training. It's not readily available because they are the critical number that need, to register, you cannot get. And if even when you get, it will end up jacking up the cost of venue and many other things. And the inconvenience it will cost you. You cannot do it in this type of hour. But if you look at the one I'm doing during weekend now, is from 6 to 8:30, Friday, Saturday, and Sunday. When people are less busy at work and they can still be going for work. During your holiday, I say, oh, I want to go for a training. Can you see the disadvantages of physical training outweigh its advantages? While the Zoom one, if I'm demonstrating, and we ask you, I demonstrate, I can ask you to share your slide and demonstrate. I tell you what to do. And other people will be looking at it. Unlike the physical training, if I go to somebody's computer, what you do, you are not doing well, do this. It's only me that is projecting. I go around to meet everybody, and it's only the person that knows the correction. Another person may be having the problem. It end up wasting time. Maybe having the problem, you have to go and solve it. At the end of the day, you learn little. Within the time, there's no time. You spend time, you learn little because you keep on attending to each person, look at the computer troubleshooting, at this one didn't get well. But if it is this one now, once I have somebody to share, if another person is having the mistake, you will understand when I correct, do this. So everybody share. If you share, everybody is looking at the person's work. If you share also, everybody is looking at your work. So you discover that within short time, you can learn a lot of things. So that's just it. So it's going to be, it has been fantastic. Many of the people here, they attended the last one and it was good. So thank you. I'm seeing the numbers. I want to see if there's any other question. Okay. Yeah. Okay. Okay. So I don't know the question, Doctor. Somebody says, I appreciate this, your practical approach, not just how to compete with software. Yes. So can we get your last lecture? Now, how do we interpret or draw conclusion between the two groups within the 2 days? I don't know what you mean by 2 days, but I know of the two groups. Dr. Joe, I don't know what you mean by 2 days.
Yes, I think you have answered the question. I posted it earlier.
Okay, sir,
we have two groups, and we are comparing like
2 days. Okay, sorry, 2 days maybe Sunday and Wednesday. Okay.
Yeah.
Okay. Those Sunday and Wednesday, they are even actually, we did it like that because the next one, we are going to treat the peer one, maybe on Monday.
Okay.
That's the essence of the 2 days. It's now parallel, the same set of people receive on Sunday. So that's why we just try to maximize to put the two method together in a page of the software. You can put it together. Yes, you can enter it together. So just to demonstrate the two methods. Okay, thank you.
Thank you, sir.
Welcome. Dr. Larry, good evening. Okay.
Good evening. How are you, sir?
Fine, sir. Well done, sir.
So we'll continue our listen tomorrow training.
Yes. I even wanted to call you. I wanted to call you. You know, I sent the slide. You saw the slide.
Yeah.
So, you know, I wanted to call you. If you go through, you'll notice that, you know, I brought in the, what do I call it? The WinPepi because of that chi-square for trend.
Trend, yes.
When I search, when I now compute an example with my hand, yes, I'm not. That same example, I try to use the formula to compute. And I said that linear by linear is the same.
Yeah. Yes. Linear by linear.
Because, you know, in the literature, there are a lot of conflicting. Some people say that it's the same, some people it's not the same. That was where I just, to be on the server side, to use the Pepi. But the problem I now have with the WinPepi was that when I try to calculate, the value slightly differ, though it's not too far from the WinPepi. I don't like that. So I now try to recalculate, removing, avoiding decimal until the last stage. So there's a way you can do to avoid decimal. So when I did that, I now see that the value is not still the same. So I started questioning that WinPepi because I didn't calculate anything with decimal until the last time. So when I now ran something with the SPSS, and I discovered that linear value is exactly what I calculated.
Okay.
Yes. So you know, somebody has said it that it is linear by label. Some people say it's not there. So because they didn't call it trend, you know, I tell you that the logic behind it is this log linear analysis. So it's only that you know what you are looking for, because even with 2 by 2 table, when there's no trend, they will compute it for you. We don't, that's computer for you, because the computer doesn't know what you want. It doesn't know what that data is for, data set is for. So that was really what really happened. I think I wanted to call you.
Okay, now I got it in the last lecture.
Exactly.
When we were analyzing SPSS, I saw the linear by linear. And you
exactly. If you see the slide I sent, all the steps, I screenshot all the steps. In the slide, I screenshot all the steps. So you can go and follow the step, just run it, you will see it there. Exactly.
Okay. No problem. Thank you.
Okay, thank you, sir. Yeah. So nobody is sending chat. Most of the time, if like for this something, and let me just pause the recording so that it won't be heavy. But if I pause the recording, any chat that come in after, it will not be safe. I will not see it later to review. That's why I usually wait when we're asking questions. So I like to. Okay.